Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 86th question of the problem solving series and the 11th question of the topic linked list. The difficulty level for this question is medium and this question has been asked in Google, Meta, Microsoft, Amazon, Adobe and many other companies. Rotate list. So we are given a head of the linked list and we are also given the amount of time we need to rotate the list. Okay, from right side. Okay, so here you can see this example. This is the linked list that is given 1 2 3 4 and 5 is pointing to null and k is equal to 2. Okay, so since we are rotating it from right, that means this 5 is going to come first in the first rotation and then this 4 is going to come at the first. Okay, so this 5 which was pointing to null will actually point to 1. Okay, and then 5 would be pointing to 1 and it would start from the linked list would be like 5 pointing to 1, pointing to 2, pointing to 3, pointing to 4. So 4 instead of this 4 would be pointing to null now when k is equal to 1. Okay, since k is equal to 2, so there will be one more right rotation, right? So this 4 is going to, so instead of rotating it from here and ending it, we are going to rotate it from here. That means this 4 and 5 will come front, 4 and 5 will come front because we have rotated twice, and then this 2, 5 will be pointing to 2, 1 will be pointing to 2 will be pointing to 3. So this would be our answer. Okay, 4, 5, 1, 2, 3. In the second example, we have 0, 1, 2 and k is equal to 4. Now when k is equal to 4, that means there are 3 numbers only in the linked list. So 0, 0 pointing to 1 pointing to 2. So if k was 3, that means once reversed 2 will be pointing to 0, 1 is at the end, then second reverse 0 is at the end, then one more time reverse 2 is at the end. So when the size of the linked list is equal to k, that means there is actually no rotation, right? So we will return the same list, return head. We don't need to make any change to the next pointer of the linked list. Okay, so this would be same, but here in this case k is greater than the size, right? So how much would be rotated? So we saw that at k equal to 3, this was the same thing, and again when k is equal to 4, so it would be rotated once, right? 2 will be pointing to 0, 0 will be pointing to 1, will stop here, right? One rotation. So that means to figure out k, we need to find out k is equal to k mod length of the linked list. Okay, so that would be our real value of k at how much we need to rotate. Got it? So how do we solve this? How do we rotate it? So you saw that in this example where we took let's write it here. Okay, 1 was pointing to 2, 2 was pointing to 3, 3 was pointing to 4 and 4 is pointing to 5, right? And k was 2. Okay, so we actually what we did, so k is equal to 2, the length of this linked list is 5. So k is equal to 2 means at this point this 3 would point to null, this would be the end point, right? And here this 4 and 5, this will come ahead and this will go here. So what we need to find to make this as null, we have to come here. So to come here we have to know length. So we find the length of the linked list. We already have done it in few questions, how we find the length of the linked list. And then we subtract this k. So when we subtract this k, length minus k, we reach over here, right? So 1, 2, 3, like this is 3. To reach 3, we have to traverse 1 time, 2 times, and we don't need to. It should, if it is less than 3, we are already at here, right? So now this one we can point to null. Got it? So this part is finished. Now before pointing this to null, we have to be here at 4, so that we can make its next, and then when this is null, this null again should be pointing to head. So we will get our rotated list, right? So let's code it. Simple, let's code it. So we find int say length is equal to, let's define a function len, give the head, and this finds the length of the linked list. Okay. It would be very simple if we code a length of the linked list. Let me code it here. Int length len list node strict head. Okay, what we will do? Int l is equal to 0, while head not equal to null. Head is equal to head next, and l plus plus. Okay, and they return l. So this would simply give us the length here. Okay, one next, 2 next, 3 next, 4 next, and then again next. So 5, and then this is pointing to null. So we'll execute and we'll get the length as 5 here. Okay, for this example. Now we have the length, we have the value k. So if we know that if length is equal to k, then we just need to return head, because there will be no change, right? We'll have this base edge case in the beginning only, so that we don't need to travel here. Okay, k would actually be equal to k mod length, the exact value of k, till what time we need to rotate. We discuss this. Next, what if head next is actually equal to null, right? Or even head is equal to null. In that case, just return head. Why do you need to write the algorithm for this? These are the direct cases, right? So we have done the right cases. Now let's do the coding that we discussed. We take a list extra pointer so that we can go back to the points. Let's take ptr1 is equal to head, ptr2 is equal to head, and ptr3 is equal to head. Fine. We have these 3 pointers pointing to the same point 1. Okay. We have this k. Now we take this int I is equal to 0. Okay. Now while I is less than length minus k minus 1, so that we come over here, right? We discussed how we get this length minus k, and since we have to go 3, we are already here, so 1 more minus we need. So we can reach this point before where we want to rotate, so that this previous point we can give it as null. Okay. While I less than 3, length head is equal to head next, and I is equal to I plus plus. Okay, finish this condition. Next, what? Now we are here actually. Now we are at this point. Always take an example to see you are doing this right thing or not. Okay, so we are here now. We want this to, and we need this pointer also, right? So one pointer should be pointing to this. So what we do, we make okay, instead of head we will do ptr1. Okay, so that again we can go in the head. So let's ptr1 is equal to ptr1 next. Okay, now ptr2 will make is equal to ptr1 next, correct? So now ptr1 is pointing to 3, it has done 3. Now ptr2 is direct, instead of pointing it head, ptr1, ptr2 and ptr3 we are pointing to this. ptr1 we went here, and ptr2 will make ptr1 next. So ptr2 is actually at 4, right? Now what we do, we will make ptr1 next is equal to null. So we have broken this. Okay, so this is ending here. Now these two linked lists are different now, they are not connected, and we are here in ptr2. Okay, so ptr2 is equal to ptr1 next, and then what we do, this is actually the end. Okay, so this is ended here, I plus plus. Okay, let me write it here, I plus plus. So this loop is ended, then this line is there. Then what will we do? We will make PTR 3 is equal to PTR 3 is equal to PTR, or we will move this one, right? So let's make PTR 3 equal to PTR 2, and while PTR 3 not equal to null, okay, till that time we will traverse it. PTR 3 next, okay, PTR 3 next, instead of PTR 3, PTR 3 next is not equal to null. We will keep on traversing it here. So PTR 3 is equal to PTR 3 next. Okay, so here PTR 3 is this point. We have done PTR 3 is equal to PTR 2. So both P2 and P3 are here. Now we will make PTR 3 point to PTR 3 next till the time it is not null. So here it is not null, so it will go here. Now this P3 next is equal to null, so it will terminate here. Okay. And now since it has terminated, its next is null, so we will make PTR 3 next, instead of pointing it was null, now we will make it point to the head. So PTR 3 next points to this head now. So this 5 has pointed to 1. Okay, and this 3 is pointing to null, but from where the node will start, it starts from 4, right? So we will return PTR 2 because this was pointing to 4. So in this way we have rotated with this example. I have dry run this code. The link to the question is given in the description. I think you have understood the solution. This is order of n10 complexity. Please check the link in the description and try it yourself, and then come to my code walkthrough section. Here is the code walkthrough of the 86th question, rotate list in the lead code platform. You can see these are the same examples that we have discussed, and these are the companies in which this question has been asked. And you can see we have the same solution here. We find the length, we write the conditions, and we have this pointer that has to be changed. So I'll directly submit it since it is the same. So it has been accepted. See you also in the next video, where I'll be explaining the 87th question of the problem solving series and the 12th question of the topic linked list. Jai Jinendra.